Welcome to Ritomo's Porosity Tool demonstration. This is Ritomo's user interface, where we have loaded the CT scan of a piston with porosity defects. Firstly, we need to perform the automatic segmentation process. There are three materials present: the air and the piston's materials with different densities. Let's switch to a slice where parts of all three materials are present. The contrast between the air and piston's materials is not big enough, therefore it is recommended to use the Levels tool to increase it. After setting the appropriate range, we select the Change Only Image View option. It is now a lot easier to set the thresholds between the materials. We adjust them, while trying to accurately enclose each material within the yellow contour lines. Subsequently, we run the seeds and grow functions to obtain the final part image, where all the voxels have been appropriately classified to their corresponding material. This is the model and volume view. It is recommended to switch to the No Volume view and enable the slice's visibility for the Porosity Analysis tool. The porosity analysis is performed on the selected part of a part image. We can adjust the settings to achieve the ideal result. For more information on how these parameters affect the analysis, please refer to Ritomo's user guide. After running the detection, all relative information is displayed in the window. By clicking the arrow on the left, we can see the geometric characteristics of all pores and toggle the visibility of the part and each pore meshes. If we disable the part's meshes visibility, the meshes of all pores can be seen, with a different color assigned to each one. By deactivating all meshes visibility, we can distinguish the projections of each pore on the specific slices as well as choose the way their marking appears. There are the solid, transparent, and perimeter options. Finally, we have the ability to disable the slice porosity markings visibility entirely. We can also export the component and inclusion meshes and later assess them in ANSA. This is what the user sees when importing all the exported meshes in ANSA. As we can see, the meshes of each pore are classified as different PIDs. Let's look at a cross-section of the whole model and see how the pore meshes are placed inside the part's mesh. The pores' placements in relation to the part are preserved. Finally, the table's contents can, of course, be exported as a CSV file. It is important to note that after closing the porosity analysis window, the results are not saved anywhere in Ritomo's database. Thank you for watching.